Hello, fourth graders. Welcome to lesson 6.6, Compare Fractions Using Benchmarks. Again, I will remind you to please include the date, the lesson, and the title, Compare Fractions Using Benchmarks, at the top of your paper. And make sure you're working in a notebook where all of your notes are kept together. If you're working on loose leaf paper, make sure you keep it in a binder just for math and keep your lessons in order. These skills are very important as a student from now until you're finished with school entirely, which would be college. This is an important vocabulary word, a benchmark. Please make sure you write this down. A known size or amount that helps you understand a different size better. When we're working with fractions, it is often appropriate to use the benchmark half when comparing and ordering fractions. So we can think of numbers closer to 0, closer to half, or closer to 1 when we are thinking about fraction benchmarks. Here we have a fraction model with fraction strips, very similar to a number line. I'll draw a number line right here. Here's 0. All the way to 1, where the fraction strips end. Here's 0, here's 1. Here is 1/2. Okay, so Zach made a popcorn snack. He mixed 5/8 gallon of popcorn with 1/2 gallon of dried apple rings. Did he use more dried apple rings or more popcorn? So we can use the benchmark half to help us understand this better. 1/2 is here, this first rectangle. And 5/8, I don't want to cover this entirely, is here, a bit further than half. So when you're using the benchmark half, 5/8 is clearly greater than 1/2. Also, if you're thinking about it just in your head mentally, you should be able to identify that 4/8 is equal to 1/2 and 5/8 is certainly greater than 4/8. Therefore, 5/8 is greater than 1/2. So using the benchmark half is very helpful when you can find the common denominator or find the equivalent fraction with the same denominator. In other words, if I'm thinking of half and I'm thinking of eighths, I know 4/8 is half. And half is always equal to a fraction where the numerator is half of the denominator. Let's look at another word problem. A family hiked the same mountain trail. Evie and her father hiked 5/12 of the trail before they stopped for lunch. Jill and her mother hiked 9/10 of the trail before they stopped for lunch. Who hiked farther before lunch? All right, let's take a look and make sure we're reading this carefully. Evie and her father hiked 5/12 of the trail. That's how far they got along on their trail before they stopped for lunch. Jill and her mother hiked 9/10 of the trail. They got 9/10 along the way before they stopped for lunch. Who hiked farther before lunch? Okay, so what I'm going to do here is use my benchmark knowledge. I'm going to take a look at 5/12, and I'm going to compare it to 1/2. Well, what is half in 12ths? Well, what's half of 12? 6. So half is equivalent to 6/12. If I compare 5/12 to 6/12, I know 5/12 is less than 6/12. 5/12 is less than half. And now if I look at 9/10 with the benchmark half, how many tenths are equal to half? Well, what's half of 10? 5. So 1/2 is equal to 5/10. I should put these in parentheses so we're not getting confused here. So if 1/2 is equal to 5/10 and I compared 9/10 to 5/10, obviously 9/10 is greater than 5/10, so 9/10 is greater than half. So that means if I compare 5/12 to 9/10, if 9/10 is greater than half and 5/12 is less than half, then 5/12 must be less than 9/10. This is how I use my benchmarks to understand and compare other types of fractions. This doesn't always work, but it often can work. Use the same procedure to compare 5/12 to 1/2 and 7/10 to 1/2, meaning use the procedure you see on this page where I make 1/2 equal to the other fraction to determine which one's greater or less than 1/2. Do the same for both of these comparisons. And then you are done. See you Tuesday, or whatever day I'll see you.